Hello Year 7s and welcome to our next lesson on fractions. Today we're going to be looking at ordering or comparing fractions. So we're looking at fractions and saying, well, which fraction is the larger fraction or the smaller fraction? Okay. So this is a bit of a recap from our last lesson. Equivalent fractions. We call fractions that equal the same amount equivalent fractions. So if you recall, we used our fraction rule and I did a bit of a demonstration to show us what equivalent fractions look like. So my first section here, I've got a half. So what's an equivalent fraction to 1 over 2? Well, 2 over 4. That's equivalent. It's the same. 3 over 6. That's equivalent. It's the same. 4 over 8. 5 over 10. And 6 over 12. So these are what we would call equivalent fractions. In the most simplest form, which we did in last class, all of these fractions would simplify to 1 over 2, a half. So here are some of the rules when we're ordering or comparing fractions. Now, I would like you to write these into your book. They are not going to make much sense when we're writing them until we do some examples. So the first thing I'd like you to do is just have a listen through these and then you can copy these into your book. If the denominators are the same, the smaller the numerator, the smaller the fraction. So it just gives us a bit of a hint. When we do some examples, it'll make more sense. If the numerators are the same, so we've got two fractions and the numerators are the same, the larger the denominator, the smaller the fraction. And we'll demonstrate that later on. When we're comparing fractions that have different numerators and different denominators, so in this case there is nothing in common between the fractions that we're comparing, we need to find equivalent fractions with the same denominator or the same lowest common denominator. Number 4, if we're trying to compare fractions and one of them is mixed or they're both mixed numbers, the first thing we need to do is convert them to improper fractions and then we can follow the rules above. Okay, so we'll convert our mixed numbers into improper fractions and we just follow. If the denominators are the same, we can understand which one's bigger. If our numerators are the same, which it probably won't be, we're probably going to have to revert back to rule number 3. Okay, but the most important thing is that we convert mixed numbers to improper fractions first before we compare them. So I'd like you to pause your screen and copy these rules into your workbook and then we'll go through some examples. Okay, moving on. So ordering or comparing fractions. So which is the larger fraction, 1 over 4 or 3 over 4? So is a quarter larger than 3/4? Now I'm going to use these rectangle sections below just to show us visually what these fractions look like to help us understand. In this case, the denominators are the same. So the smaller the numerator, the smaller the fraction. Denominators are the same. Well, 1 is smaller than 3. So that means that a quarter is going to be my smaller fraction here. So which is larger? 3/4. Let's just have a look. So 1/4 actually means 1 part out of 4. 3/4 means 3 parts out of 4. So we can see that 3 parts out of 4 is my larger fraction. So I've got 3 over 4 is the larger fraction. These 3 dots mean therefore 1 over 4 or a quarter is less than 3/4. Just to remind us about less than and greater than, it's always eating the larger number. Picture this as being a mouth. It's eating the larger, in this case, the larger fraction. So which is larger, 7/8 or 5/8? Again, I would say to myself, I've got 7 parts out of 8 or I've got 5 parts out of 8. So I know if I've got 7 parts out of 8, the larger my numerator, because my denominator is the same, the larger my numerator, the larger the fractions. So if the denominators are the same, the smaller the numerator, the smaller the fractions. Let's have a bit of a look and see what it looks like visually. So here I'm actually going to be showing you what 7 parts out of 8 looks like. And now I've got 5 parts out of 8. So we can see that 7 parts out of 8 is the larger fraction here because more of it is shaded. Therefore 7/8 is my larger fraction. Okay. And as we see, 7/8 is greater than 5/8. In this case, I've got the same numerator, but different denominator. So let's have a bit of a look. And you can see that I've got one of these rectangles split up into 4 equal parts and the other is split up into 5 equal parts. So if my numerators are the same, the smaller or the larger the denominator, the smaller the fraction. So 1/5 is going to be the smaller fraction. And let's have a bit of a look. I've got 1 part out of 4, or I've got 1 part out of 5. Now you can see in this case that 1 part out of 4 is slightly larger than 1 part out of 5. Okay? So 1/4, or 1 part out of 4, or a quarter, is greater than 1/5. So 1/4 is a larger fraction. I've got 3/6 and I've got 3/8. So 3 parts of 6, 3 parts of 8. I'm using the same rule here again. Okay. This is what 3 parts out of 6 looks like, which is equivalent to a half, because half of that larger rectangle is shaded. And this is what 3 parts out of 8 looks like. So again, which one is the larger one? 3 parts out of 6 is the larger fraction. Therefore, we can say that 3/6 is greater than 3/8. Now, which one is larger? I've got 7/10 or 7/8. Now again, I've got 7 parts out of 10 or 7 parts out of 8. Now 7 parts out of 8 is going to be larger because more of it's going to be shaded. So let's have a bit of a look at what 7 parts out of 10 looks like. And now we're going to compare 7 parts out of 8. There you go, we can see that 7/8 is the larger fraction. So therefore 7/10 is less than 7/8. Okay? So just try and say it out loud to yourself to try and think about which is larger and smaller. So if we're calculating equivalent fractions, this is a bit of a recap from our last lesson. When you multiply the numerator, the top and the denominator, of a fraction by the same number, you get an equal fraction or an equivalent fraction. Really important that we multiply the numerator and denominator by the same number. I've got 2/3. If I multiply my numerator by 2 and my denominator by 2, I end up with 4/6. Okay? So 2/3 and 4/6, they're equivalent. They actually equal the same amount. I've got 3/4 and 9/12, they're equivalent. How do I know that? Because I've multiplied my 4 by 3 and my 3 by 3. I've multiplied by the same number, my numerator and denominator. Again, I've got 4/5 and 16/20. How do I know that they're equivalent? Because I've multiplied my numerator and my denominator by 4 in this case. So multiples, this is something that we did in Term 1. In fact, this same slide is found in our Term 1 classes. Multiples of a number is the answer obtained when that number is multiplied by another whole number. So when I think of multiples, I think of my times tables. What are my multiples of 2? 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8, and so on. So 2, 4, 6, 8, 10, 12, and so on. Again, my multiples of 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4, and so on. My multiples of 7. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. So again, multiples of 7, my 7 times tables. Now the lowest common multiple, so LCM, something that we did in Term 1, the lowest common multiple between 2 or more numbers is found by identifying the lowest common number. So the lowest common multiple of 2 and 4. So I look at my multiples of 2, look at my multiples of 4, and I'm looking for the lowest common, which is the same, and the lowest number that's the same. In this case, 4 is the lowest multiple, common multiple, between both 2 and 4. 8 is common, 12 is common, but the lowest one of those is 4. So 4 is my lowest common multiple. And another example, what's my lowest common multiple of 2 and 7? Well, I can see that 14 is the lowest common multiple between 2 and 7. Now, there are going to be more multiples. For example, I know that 28 is a multiple of 2 and 7, but the lowest one that's common to both is 14. And that's going to help us when we're trying to determine lowest common denominator. So we're going to be ordering these fractions. Now this is when it gets probably a little bit tricky when we're comparing fractions. So which fraction is larger? Now again, in this case here, I would suggest, and the rule suggests, that when we're comparing fractions with different numerators and different denominators, we need to find equivalent fractions that have the same denominator. Okay, in this case it says the lowest common denominator, but they need to have the same denominator. Now in this case, and in some cases, the first check we should do is say, is 8 a multiple of 2? And if it is, then we don't need to convert both of these fractions. So let's just go through that process. I know that 8 is a multiple of 2, so I'm going to convert my 1 over 2, or my half, into a fraction that has a denominator of 8. Why am I going to do that? So that when I'm comparing this newly created equivalent fraction, it'll have the same denominator and it's a bit easier for me to compare. So how do I find an equivalent fraction of 1 over 2 so that 8 is my denominator? Well, what I do is I say to myself, what do I need to do to 2, or what number do I need to multiply 2 by in order to make it an 8, sorry. If I multiply 2 by 4, it'll give me 8. Now we know when we're trying to find equivalent fractions, the numerator and the denominator must be multiplied by the same number. So I'm going to multiply 1 by 4. So I know that a half, or 1 over 2, is equivalent to 4 over 8. Now when I compare my fractions, is 4 over 8 larger than 3 over 8? And in this case, it is. So my larger fraction happens to be the half, because we know that 4 over 8, which is equivalent, is the larger fraction. Okay. Having a look at I've actually shown it to you here visually. So this is 1 part out of 2, or a half. You can see that more of this is shaded than 3 parts out of 8. And now I'm just going to convert this rectangle so that it has 8 equal parts, and there we go. So a half is equivalent to 4 over 8, and 4 over 8 is larger than 3 over 8. So a half is the larger fraction. Okay, so a half is greater than 3 over 8. Again, I've got 2 fractions. Okay, my denominators, nothing is in common between these 2 fractions. But what am I going to do? Well, we need to find the lowest common denominator. Now, what's common to both of these 2 fractions? Well, I know that 12 is a multiple of 3. So I'm only going to convert my 1 over 3 into a fraction where 12 is going to be the denominator. Okay, so I've got 1 over 3. I now want to convert that into an equivalent fraction where 12 is the denominator. Now I ask myself, what do I multiply 3 by in order to make it 12? Well, I know that if I multiply 3 by 4, it'll give me 12. Equivalent fraction means that I must multiply my numerator also by 4. So let's multiply 1 by 4, and I get 4 twelfths. So what this is telling me over here is that 1/3 is an equivalent fraction to 4 twelfths. These are equivalent, they are equal. It's easier to compare 4 twelfths with 3 twelfths to determine which one's bigger. Okay, I've got 4 parts out of 12, or I've got 3 parts out of 12. And we know that if the denominator is the same, if my numerator is larger, that means it's a larger fraction. Let's have a look and see what it looks like graphically. So here is 1/3. I've got 3 equal parts. One of those is shaded. I've got 3 parts out of 12 shaded below. We're not going to be able to draw these nice pictures every time we're comparing graphs, but I'm just going to demonstrate for you that now if I convert 1/3 into 4 twelfths, so now I've got 4 parts out of 12, or 3 parts out of 12, it's very clear that 1/3 is the larger fraction. So 1/3 is greater than 3 over 12, because we know that 1/3 and 4 twelfths is equivalent. Okay. Which fraction is larger? I've got 2/5 or 2 over 5 or 5/10. Again, nothing is in common. So the first thing I should do is actually ensure that I have a common denominator when I'm comparing my fractions. So let's go through and compare them and have a look. I know that 10 is a multiple of 5, because 2 times 5 is 10. Okay, so if I need to multiply 5 by 2 to get 10, I now need to multiply my numerator by 2, and that'll give me 4, because 2 times 2 is 4. Now, when I'm comparing these 2 fractions, I'm going to be comparing 4/10, because that's equivalent to 2/5. 4/10 or 5/10. Which is the larger fraction? Well, we can see that if my denominator is the same, 5/10 is the larger. Just to show it to you now visually what it looks like, I have 2 parts out of 5, or I've got 5 parts out of 10. We can clearly see that 5 parts out of 10 is larger. But now I'm going to show it to you so that both of these are out of 10. There we go. 4 parts out of 10 versus 5 parts out of 10. So once we have common denominators, it's easy to compare. We don't need to draw graphs, and we won't be drawing these nice pictures to help us. We just look at our fractions and compare them. Same denominator. If my numerator is larger, it's a larger fraction when the denominators are the same. So 2/5 is less than 5/10. Another example here. Again, this one's a little bit different. So in this case here, I've got 2/3 and 4/5. Now, 5 is not a multiple of 3. And 3 is not a multiple of 5. So now we need to actually think of what is the lowest common multiple of these two numbers. So we're actually going to have to find equivalent fractions for both of these. In previous examples, we only found equivalent fractions of 1. So let's just go through this process. Now I know down here, and I've written here to help us, 15 is the lowest common multiple of both these numbers. Okay. Now how are you going to determine this? Well, for those of you that are pretty quick with your times tables, you should be able to work that out. Some of us are going to have to refer to a times table chart to help us. So you should have that handy. It's going to be important for us throughout this unit of fractions. So 15 is the lowest common denominator of both these fractions. So now we need to find equivalent fractions where 15 is the denominator. What do I multiply 3 by in order to make it 15? And what do I multiply 5 by in order to make it 15? So let's have a bit of a look. So 3 times 5 is 15. That means that I need to multiply 2 by 5. So 2/3 is equivalent to 10/15, or 10 over 15. Let's move across to our next fraction. What do I multiply 5 by to make it a 15? Well, 5 times 3 is 15. What am I going to multiply? I need to multiply 4 by 3 because that's what I've done below. 4 3s are 12. So now when I'm comparing 2/3 and 4/5, that's a hard comparison. And we're not going to be able, some of us won't be able to look at that. It's going to be tricky for most of us to say which one is larger. But if I compare 10/15 and 12/15, that's a lot easier. Common denominators, larger numerator, larger fraction. So 4/5 is the larger fraction in this case. So we're going to have a look and see what these actually look like. So here I have, in this first rectangle, I've got 2 parts out of 3. In the image below, I've got 4 parts out of 5. So we can see that 4/5 is the larger of the two fractions. And now I'm just going to make them into equivalent fractions. I've got 10 parts out of 15, and I've got 12 parts out of 15. We can see that 12/15 is the larger fraction, which is equivalent to 4/5. Okay? Now we always go back to the original fraction, so 2/3 is less than 4/5. So which fraction is larger? 3/4, 3 over 4, or 5/6? Again, nothing is in common. So what am I going to need to do? I'm going to have to find equivalent fractions where I have a common denominator between the two fractions. Now, 6 is not a multiple of 4. And 4 is not a multiple of 6, so I'm going to have to find the lowest common denominator between these two numbers. Again, if we're good with our timetables, we'll know that 12 is common to both. For those of us that aren't, we're going to have to refer to our times table charts and look and see what's the common lowest common multiple for both 4 and 6. So, I know that 12 is going to be my new denominator because that's what's common, that's the lowest common denominator between these two fractions. So I now ask myself, what do I multiply 4 by so that it becomes 12? Well, 4 times 3 is 12. 3 times 3 is 9. So 3/4 or 3/4 is equivalent to 9/12 or 9/12. I now look at my 6 and say, what do I need to multiply 6 by to make it a 12? I've got 6 times 2 is 12. Therefore, I need to multiply my 5 by 2, which is 10. Now, when we're comparing these two fractions up here as equivalents, I'm comparing 9/12 and 10/12. Well, 10 parts out of 12 is going to be larger than 9 parts out of 12. So which fraction is larger? 5/6 is the larger fraction. Looking at it graphically, how does it look like when I draw these fractions out as a picture? Well, I've got 3 parts out of 4, and I've got 5 parts out of 6. We can see that 5 parts out of 6 is larger. We're not going to draw these pictures, so let's have a look and see what they look like if we convert these to equivalent fractions. So now I've got 9 parts shaded out of the 12, or I've got 10 parts out of the 12 shaded. We can see that 5/6 or 10/12 is the larger fraction. So 3/4 is less than 5/6. Doing another example again. Which fraction is larger? Again, think about our rules. What do I need to do first? First thing I need to do is find a common denominator. Now, 9 is not a multiple of 6, and 6 is not a multiple of 9. So we need to find what's a common denominator for both of these two. Again, I know that 18 is a multiple of 6, and 18 happens to be a multiple of 9. So now I'm going to find equivalent fractions. What do I multiply 6 by so that it becomes 18? 3. 6 times 3 is 18. I therefore need to multiply 5 by 3, which will give me 15. Again, what do I need to multiply 9 by to make it 18? Multiply it by 2. 7 times 2 is 14. So I've got 15/18 or 14/18. So 18 is the lowest common denominator of both fractions, so we can find two equivalent fractions with a denominator, in this case 18. So now I'm not comparing 5/6 and 7/9, I'm comparing equivalent fractions. 15/18 and 14/18, very similar sized, but I know that 15/18 is my larger fraction. So 5/6 is a larger fraction. Let's have a look at what it looks like graphically. I've got 5 parts out of 6 shaded, and I've got 7 parts out of 9 shaded. We can see here, they're very similar, but 5/6 is the greater fraction. I'm now going to convert it to equivalents. 15 parts are shaded out of the 18. 14 parts are shaded out of the 18. So again, same denominator, the larger the numerator, the larger the fraction. So 5/6 is greater than 7/9. This is now getting a little bit tricky. This is probably as hard as it's going to get. But we need to order all of these fractions in ascending order. And for those that have forgotten, it means smallest to largest. I've got 3/5, 11/20, 1/2, or a half, 7/10, and 3/4 or 3/4. So what's the first thing we need to do? If we go back and check our rules quickly, first thing we need to do is make sure we've got a common denominator. So the lowest common denominator of all these fractions, again, I would have a look and see what's common of all of these. In this case, we can use the 20, because 20 is the lowest common denominator. So now I'm going to convert all of my fractions to an equivalent fraction where 20 is my denominator. I obviously don't need to change the 11/20 because that's already correct. But I asked myself, what did I multiply 5 by to make it into a 20? Well, we know that 5 times 4 is 20, so I must multiply my numerator by 4. So 12/20 is equivalent to 3/5. 11/20 is going to stay the same. Again, what do I multiply 2 by? In order to make it 20, I need to multiply it by 10. Therefore, my numerator must be multiplied by the same amount. So 10/20 is equivalent to 1/2. Again, I multiply 10 by 2 to get 20. I need to multiply 7 by 2 because it's the same, it's equivalent. That gives me 14. 4 times 5 will give me 20. So therefore I need to multiply 3 by 5, and that'll give me 15. So when I'm comparing and ordering these fractions, now I'm going to use those that are within this red rectangular section. Okay? It's much easier to compare when the denominators are the same. And we know that the smaller the numerator, if I have common denominators, the smaller the fraction. So which fraction is the smallest out of these 5? Well, 10 over 20 is my smallest, but I'm going to write it as it is originally given to us as a half. My next smallest is going to be 11/20, and that will stay the same because it was originally given to us as 11/20. The next smallest is 12/20, but I'm going to write it as 3/5. And we continue, 7/10 will be the next smallest, and 15/20, which is 3/4. So I have just ordered the fractions from smallest to largest in ascending order, and I've kept the original fractions that were provided to me. It does involve a few steps, as you can see. Just looking at it graphically, I've got 1 over 2 or a half, I've got 11/20. Now, when they're drawn like this, it's easy to compare and see which one's larger. But what did we do? We converted them all so that they had a common denominator of 20, and then we don't need to draw pictures. If they've all got the same denominator, we can nicely see that 10/20 is the smallest, 15/20 is the largest, and we can order them based on the size of the numerator when the denominator is common. So this is our last example. We're ordering these fractions in ascending order. Now, rule number 4, the last rule that we wrote down very early on in this class, it said that if we have mixed numbers, we must convert them to improper fractions. So I've got 2 fractions here which are mixed numbers. I've got 1 and 3/5, and I've got 2 and 1/4, or 2 1/4. So I need to convert those two into improper fractions. And the way that we do that is we say that 1 times 5 is 5, plus 3 is 8. So 8/5 is now an improper fraction of 1 and 3/5. Now 7/4 remains the same, 3 over 2 remains the same. 2 1/4, 2 times 4 is 8, plus 1 is 9, so that becomes my new numerator. So 9/4 is equivalent to 2 1/4. And 11/5 stays the same. So now what am I going to do to compare these fractions? I need to order them from smallest to largest. I need to get a common denominator. Okay, my lowest common denominator. Now in this case, my lowest common denominator happens to be 20. 20 is my lowest common multiple of 5, of 4, and of 2. Okay? So I can put that in as my new denominator. And then I ask myself, what do I multiply 5 by in order to make it a 20? 4. 5 times 4 is 20. I need to multiply the numerator by the same number. 5 times 4 is 20. 5 times 7 is 35. 10 times 2 will give me 20. 10 times 3 will give me 30. So again, 5 times 4 will give me 20. I need to multiply by 5 again, 45. 4 times 5 is 20. 4 times 11 is 44. So once we have got a common denominator, it's much easier for us to compare and order these fractions. If the denominator is the same on all the fractions, the smaller the numerator, the smaller the fraction. So now I can put my smallest fraction is going to be the one with the smallest numerator, which is this one here, 30 over 20. So 30 over 20 is the same as 3 over 2. That's my smallest fraction. I can look again for the next smallest one, which will be 32 over 20. But I'm going to write what I was originally given, which was 1 and 3/5. I now look at my next smallest, which is 35 over 20. I'm going to write that as my original fraction in the most simplest form, 7/4. 44 over 20 is my next smallest, and I'm going to write it in its most simplest form, which is 11/5, or 11 over 5, and 2 1/4 is my next. So yes, there's a few steps involved, and practice will help. There's a lot of examples in this PowerPoint presentation. You may need to watch it again just to help you understand, but hopefully when you do some practice, you'll be able to pick up this skill and be able to order and compare fractions. So refer to your lesson logs for the exercises or work that needs to be completed as part of this class. Thank you.